and there is various cases when the lift is moving upwards or when the lift is moving downwards, sometimes with an acceleration g, sometimes with an acceleration greater than g, etc. So here our case 1 is when the lift is moving upwards, okay, when the lift is moving upwards, and here we consider a lift like this and an object of mass m is within the lift and the lift is moving upwards with an acceleration a, and here our aim is determine the force acting on the mass m. What are the various forces that are acting on the mass m? And here two main forces, one is mg and another is normal direction n. But this normal direction n will be equal to mg when the lift is in rest. But when the lift is moving upwards, then the normal directions that the person feels the weight will be changed. What will be the thing? If we draw the free body diagram of m with respect to ground, this is the, let me consider this is a ground and the FBD with respect to ground, that is with respect to the inertial frame of reference. Then the weight mg will act downwards and normal direction n will act upwards. And here the acceleration a is upward direction. So if we talk about the Newton's second law, then summation Fy will be mass into acceleration ma. And here summation Fy will be n minus mg because acceleration is upward direction, so upward direction is a positive direction. So here will be n minus mg equals to ma. So n will be equals to mg plus ma. So this is the normal reaction that the person feel, the weight. So here the normal reaction is increases by an amount ma. This means the weight that the person feels will increases. So the person, the weight, I write down here, I can write down here the weight the person feel will be increases. Okay, when the lift is moving upwards. But if the lift is moving downwards, if the lift is moving downwards, that is case 2. Okay, then what will be the thing? Moving downwards, case 2. Okay, acceleration is a, downward direction. Then the free body diagram will be, here in this direction is n, this is mg, and the acceleration is downwards. So here the summation Fy will be ma, but here the positive direction is in the downward direction because the acceleration is in the downward direction. So mg minus n equals to ma, and n will be equals to mg minus ma. So here the normal reaction is decreases by an amount ma, that is mg minus ma. Mg is the actual weight of the person. If there is a person, the mg is the actual weight, and n is the weight that he feels, and the weight that he feels is decreases due to the acceleration downwards. So here normal reaction is decreases. What amount? By an amount ma. Okay, but if the acceleration of the lift is equals to g, that is if the lift is falling freely, then the normal reaction will be 0, that is n equals to mg minus mg, and that is 0 because a equals to g. So this normal reaction n equals to 0 means the person feels no weight. That means this is the condition of weightlessness. This is the condition of weightlessness. When the person feels no weight, when the acceleration of the lift is same as the gravitational acceleration, that is lift is freely falling. But if the lift is falling with with acceleration more than g, if a is greater than g, here a, this is the condition. If we talk about this is a case 3, then this is the condition when a equals to g. But if we talk about a greater than g, then what will be the thing? If we talk about a greater than g, that is case 4, you can say, that is a greater than g, but moving downwards. If a greater than g, here actually when n equals to g, then there is no contact between the lift and the object, because normal direction 0 means there is no contact force, there is no contact between the object and the floor of the lift. So in that case, the mass m will fall freely with the gravitational acceleration g, because there is no contact. But if the acceleration of lift is greater than g, that is a is greater than g, then the acceleration of this frame will be greater than g. This means that the objects which are within the lift are moving downwards with an acceleration g, because they are freely falling. But the lift is moving downwards with the acceleration greater than g. So what will be the thing? The acceleration of this frame will be greater than this acceleration of this object. So when this is moving downwards with greater acceleration, then the distance between the roof of the lift and the mass m will continuously decreases, and very shortly this object will reach to the roof of the lift, and all the objects which are within the lift will be attached to the roof of the lift, and that condition is called super weightlessness. Okay, super weightless.